Hello everyone and welcome. Welcome to this event on financing CCUS, a clean technology, a key clean technology for industry. My name is Juho Lipponen. I'm the coordinator of the Clean Energy Ministerial CCUS initiative, and it's my pleasure to be the host of today's event. And we are here at the evening session of the 2021 Asia Clean Energy Forum that's organized by ADB, and we are also running this side event together with Asia Development Bank. So thank you very much to our ADB colleagues for the collaboration. Our audience is in listen-only mode today, but you can put through your questions via the Q&A tab function in the Zoom system. And here's the agenda for today. After some welcome by the SEM Initiative and ADB, we will hear from the Oil and Gas Climate Initiative on strategic CCUS hubs in Asia. We will then move to a session on CCUS in the industrial sectors. After that, we will have a discussion on how to finance CCUS. And also in two spots of the agenda, we will have an occasion to engage in dialogue and discussion with the speakers and take your questions. So we hope this will be very interesting for you all. And here is our wonderful speaker panel today. And I would like to ask all our speakers to turn their cameras on for a second, just to wave and say hello and show your faces. And you will get to learn to know all these speakers as we go along, and they will present themselves when they start to speak. We are from many parts of the world today, from Regina, Saskatchewan to New York City, Oslo. We also have Amsterdam, London, and Vienna, and obviously ADB is in Manila. So we cover a lot of ground. So in the beginning, myself and Kei Nam will give some brief introductory remarks to this event. The Clean Energy Ministerial is a global process that brings together 29 member countries from across the globe to collaborate on clean energy deployment. SEM members make 90% of global clean energy investment, but are also responsible for 3/4 of the CO2 emissions. So this is a very relevant global partnership. The SEM process has several work streams across all clean energy sectors, carbon capture being one of them. And on the right-hand side, you see the flags of our SEM CCUS initiative members. We have 12 members from the SEM governments, and our joint objective is to accelerate CCUS together. We work on strategic and policy level. Our work is government-led, but it's not government only. So we are very open to collaboration with industry, with financial institutions, and key organizations. And I would simply like to highlight that the 12th Clean Energy Ministerial took place during the first week of June. And there was a wealth of clean energy program available. And you see the SEM 12 website at the bottom of this slide. All the contents, hours of content, various events are still available on that website. So please go and have a look at all these events, including the 3 CCUS events that we put together. And with that, I would like to invite Kei Nam, the principal energy economist at the ADB, to give welcoming remarks from the ADB side. Kei, please.
Thank you, Mr. Lipponen, distinguished panelists, participants, and colleagues. A pleasant day to all. On behalf of the ADB, it is my pleasure to welcome everyone to this side event on financing carbon capture, utilization, and storage, a key clean technology for heavy industry. It is good to see colleagues from the financial community who support the financing of the CCUS. ADB would like to be at the forefront of the new developments with you. ADB continues to promote CCUS in Asia and the Pacific by conducting feasibility studies, preparatory activities, and importantly, capacity building events through a couple of technical assistance that the energy sector group, the ADB, is maintaining at the moment. In addition, that ADB or energy sector group administers the carbon capture storage fund, which is roughly, but we have certain, roughly at the moment around about $13 million, which is available for exploring the carbon capture storage technologies. Early this year, we published the Carbon Capture Utilization and Storage Game Changers in Asia 2020 Compendium of the Technologies and Enablers. ADB is on the lookout for promising CCUS concepts, applications, and business models, and could extend financial and technical assistance. ADB can provide support at any stage from feasibility to demonstration. There are several, so to say, instruments that the ADB is having, which includes a direct grant, concessional loan, bank guarantee, or the technical support. We are happy to partner with the Clean Energy Ministerial's CCUS initiative and other financial institutions and expert partner institutions to promote CCUS with the financing tools in the region. Allow me to thank you for taking time to attend this special event. Thank you to CEM and its partner organizations for organizing this event and putting together this panel of experts. I look forward to vibrant interaction among our panelists and the participants. Thank you.
Thank you very much, Kyung-Nam, for your introductory remarks, and certainly a pleasure to collaborate with you. And we've obviously had lots of collaboration and interaction in the past, and hopefully continue to do so far into the future. Thank you for your intervention, and please remain with us as long as you can. And I understand that you also have some other obligations that you have to run to after this. So we will then move on the agenda and jump right into the first substance session. And this is given to us by Ian MacDonald, who is CCUS lead at the Oil and Gas Climate Initiative. And Ian will talk to us about the global search of various new strategic CCUS hubs around the world. So Ian, please take it away.
Thank you. If you could move on to the first few slides, thank you. And the next one. And so a quick introduction to who we are as OGCI, the Oil and Gas Climate Initiative. Effectively, it's 12 of the IOCs and NOCs around the world, and we account for around about 30% of the world's oil and gas production. So a good collective of representatives from that industry. And particularly what's quite unique about the OGCI is that we are CEO-led. The CEOs meet on a regular basis to discuss climate initiatives and also particularly focus on CCS. You see CCS is highlighted there as one of our focus areas that we have quite a few of, but CCS is certainly a very important one. And all of our companies have a commitment towards making the Paris Agreement. As part of the OGCI, what the companies have also done is contributed into a climate investment fund, a $1 billion pot of money to look at investing in CCS projects that are not from our member companies and also new technologies. But we won't go into that in too much detail in this presentation. If you can move on to the next slide. So what happened was in 2019, well, earlier than that, but we identified and we launched in 2019 our Kickstarter initiative, where we could see that we really needed to collaborate and work together as not only an industry, as the oil and gas, but actually as a wider societal effort to make CCS happen, and particularly from this hub perspective. The previous projects of sink to source, source to sink CCS projects were sort of becoming a bit dated, and we're seeing that we're having to gather together the high purity CO2, low cost emissions, gather them first into a collective hub for storage in potentially one reservoir. We saw that as a way to help cross the barriers that were in the way for CCS to be deployed initially before we can get a stronger carbon price and therefore make CCS more competitive in the decarbonisation arena. So we identified a number of hubs, and we've expanded that recently to other more high potential ones where we don't have a project assigned to those hubs, but we're working actively in that area to develop projects and also work with our other emitters around that area to make this happen. But our main hubs are the ones that you've already heard of: the Northern Lights, Net Zero Teesside, Rotterdam, which is the Porthos project. So in that case, we're the emitters. We contribute the CO2 into the transport and storage infrastructure. And we also have one in China, run by CNPC. And our hub characteristics are very broad. We're looking at taking CO2 from any source. And we're not limiting it. We're not being choosy and just going for the oil and gas. But effectively, what we're wanting to do with this initiative is to drive forward the CCS deployment by working collaboratively and helping those industries who may not necessarily understand the subsurface too well, and bring our expertise and allow that to be create the full chain project for that set of industries that need sort of that help with the subsurface knowledge and someone to manage subsurface on their behalf. And so we've done quite a lot of work on this. We're looking at how to develop new ones. And the big issue that we sort of identified about a year and a half ago was, so we've got these projects that our member companies were basically already promoting and pushing through, and we've now gathered them together in our hubs. But what's the next phase? And why isn't CCS kicking off in other parts of the world? As you can see from our map, it's very concentrated in Northwest Europe and North America. So what are the missing ingredients in these other parts of the world? So we wanted to look at that, and so we started to put together a study to look at global hub search for CCUS. So if you go to the next slide, I'll briefly talk about that and then sort of the premise of what that was to do. If you go to the next slide again. So again, the countries in black are countries we omitted from our study, partly because we either have hubs, so they have a very mature CCS framework and regulatory environment, but also we'd already started looking intently within Saudi and China, and we have white papers on those two countries already. So we basically looked at the countries in green and blue, and the only difference there was a time lag in actually doing the studies. The green studies had quite a lot of data readily available for us to use, so we could run them as a phase one and a trialing of our modeling aspects. But we realized that we really need to grow that funnel and looked into other countries around the world, as you can see from all those in the blue. So if you go to the next slide, how we developed this model was effectively we looked at the emission data that we could gather or estimate for each of the emitters in those countries. And then also we tried to look at, well, where's the storage? Where are the likely stores going to be? And what are the potential capacities of those stores, both a saline aquifer and oil and gas reservoirs. And we also looked for the pipelines locations, so we don't understand the rights of way and where the process could already see a pipeline potentially being built. And then for those emissions, we broke it down into different types of emission categories, so we could then estimate the capture cost for those categories, being both high purity and low purity. But then also look at, well, how much will it cost to actually take the CO2 from those emitters, put it into a transport network, and get it to that potential store site that would be nearby. We then also applied a qualitative analysis of the local countries. What was the situation with respect to CCS being mentioned in the NDCs, which is a very encouraging sign? Are there any local carbon taxes that would help CCS sort of bridge that technical economic gap that we have in a lot of domains? Is there any emission trading scheme, etc.? Is there CCS projects already there or announced? These were also a qualitative lens that we could apply to understand the CCS environment within that country. And so we did that for 52 countries around the world in the end, and we're sort of looking at them now to see where we can take them further. So if you go to the next slide, we see the sort of big scale results. So globally around the world, there's over 200 hubs we identified as having quite a reasonable amount of CO2 that could be stored somewhere. And we categorize these in different tiering system that we utilize. Tier 1, which is basically less than $50 per ton. So effectively, those hubs would initiate themselves on a very low-cost, high-purity CO2 stream, and other tiers going up to over $100 per ton. And you can see all the dots there on the global map as to where they are. The green ones are particularly the really sweet spots where we can see there's a concentration of high purity CO2, and for that country there's luckily some storage nearby that can be utilized and keep the costs sufficiently down. For Southeast Asia area, if you look on the map on the right, you'll see a sort of a screenshot of our graphic user interface that we can utilize, and we can zoom into different countries and see all the different emitters and where they are potentially clustered and put within a hub within the model. All the different colors on that map indicate a different type of emitter. So the sort of very aqua light blue would be a fossil fuel generator, whereas the other colors can be cement or iron and steel, for example. And some different colors that represent a different industry. And so they're the sort of broad spectrum of emitters, and we had many thousands of emitters in this database for the study. But the good thing is that, globally at these 52 hubs, we were looking at around about 6 gigaton of emissions within those hubs. I mean, we understand that we're not going to be able to decarbonize all those 6 gigaton of emissions. There will be other decarbonization levers taken. That gives you the sort of order of magnitude of the opportunity here. But within the particular focus area of Southeast Asia, again, we could say that there's about 3 gigaton of CO2 annual emissions from this location, and particularly India being quite a large emitter, as you can see on the map. But you can also see point source emissions. There's quite large ones in various Southeast Asian countries and also the likes of Korea. And within this focus area, we're really looking at, we probably identified about 43 potential hubs, or less than $100 per ton. So this is a sort of good indicator that there's a lot of potential to be done within Southeast Asia. If we can bridge that commerciality gap right now, the carbon prices in a lot of countries is very low if a carbon price exists. But generally speaking, we also identified some real positive CCS environments. Canada was the leading one, followed by various countries, including some in Southeast Asia. Another aspect we looked at was the storage options. This is a very high-level storage assessment, and we really did see that there was some limitations in certain parts of the world on our storage, and that may be due to and simply the fact that we don't know about it. This is all done publicly available data, but certainly there needs to be quite a lot of work done on storage appraisal work going forward. And for Southeast Asia in particular, there was a good potential here for transport and storage collaboration, particularly when you look at the likes of Singapore and Japan and potentially Korea, who are struggling to potentially meet their full CCS storage demands with local storage capability. So they're looking potentially to move that CO2 to other countries. If you go to the next slide, just focusing on CO2 storage, another part of work that OGCI does is looking and going through and assessing a country's storage resource management classification system. And we've basically been through a whole bunch of countries trying to understand how bankable are the storage resources in these countries. And this is all publicly available on our website. And we've done some in Southeast Asia, and we plan to do even more in the next 12 months as well to get them into the resource catalog and to maybe make sure we understand what are the actual storage resources from a verifiable system, classification system available for our projects that we may be interested in cascading. And next slide. So just to summarize, basically, OGCI, really what we're wanting to do is to share the knowledge of our member companies and also the success factors from the various hubs that we're developing now and looking forward to develop. We want to really have a joint collaborative work on the value of CCS in a local context. As I said, we've done this with Saudi and China, and we're looking to do that in the next near while in other countries, really focusing on these high potential hubs and the mechanisms to deploy that, and what are the right policy mechanisms that countries need to consider to adopt. And then also we really are very supportive of any public-private collaboration, particularly the likes of the CEM initiative. And going forward, we also want to really start looking at collaborative work on on CO2 storage resource assessment, and also just being able to get that data into this resource catalog that we have publicly available. So I'll draw close to my presentation there, if that's all right, Juho, and passing on to the next presenter.
Thank you very much, Ian. That was really neat and excellent, and I think it's really groundbreaking work that you've been doing with OGCI. You have to be really commended for this, because we need to be practical about this, see where these opportunities are, and start identifying at what cost you might be able to do them, and move from a high-level discussion to something that is very practical. And this is a great step in that direction. So excellent. And there's already some questions in on this topic. We'll be coming back to them after the next three interventions. So thanks, Ian, for this. I'm going to stop share here, and we will move to the three interventions on CCUS in industrial applications and for industrial sectors. And we will first hear from the IEA and Samantha, who will give us some interesting insights and figures from the IEA's work. Samantha, please.
Well, thanks so much, Juho, and good evening, everyone. It's really a great pleasure to be with you. I'll just try to get my slides up for you. So, no, it's such a pleasure to be able to share some of the insights related to carbon capture, use and storage from our recent Net Zero 2050 roadmap. This is a report that we released just last month. And really the report was something that we produced really responding to the growing momentum behind pledges to achieve net zero. Typically, these pledges are targeting mid-century, although we recognise some countries are aiming to achieve this target earlier, some a bit later. And to date, these pledges cover around 70% of global GDP and CO2 emissions also. And really, the aim of the report was to ask the question of what would it take for the entire global energy system to reach net zero by 2050. And so the answer is really that it does require a fundamental change in how we use, transport and produce energy. And there are many milestones along the way. So just to highlight in particular some of the CCUS milestones, if I can bring them up. So by 2035, we would see around 4 billion tonnes of CO2 being captured each year. So this is up from around 40 million tonnes that we see today from 20 or so projects. By 2050, when we do achieve net zero, around 7.6 billion tonnes of CO2 is being captured from a range of sources. Now, this very ambitious scale up really reflects the challenges, but also the opportunities inherent in a 2050 net zero pathway. We would need a major boost really across all technologies, not just CCUS. And just to provide some context around what would need to happen just in the next decade, so in the period to 2030 with some other technologies. To give you an example, energy efficiency improvements would need to be implemented 3 times faster than we've seen in the past 2 decades. For solar and wind capacity, this would need to be installed at 4 times the record that was set in 2020. And electric vehicles would go from around 5% of car sales today to 60% by 2030. So there is an ambitious task ahead to achieve this rollout. But just looking specifically at CCUS, it would require really an immediate acceleration in the rollout of projects to be consistent with a net zero by 2050 pathway. By almost 1.7 billion tonnes of CO2 would be captured each year. Again, this is up from 40 million or so tonnes today. And in our analysis, CCUS is applied in many sectors. This is from fuel transformation to hydrogen production, biofuels production, in heavy industry, in the power sector, and also technologies such as direct air capture start to emerge in the next decade. During this period to 2030, around 70% of the growth in CCUS come from low carbon hydrogen production, from heavy industry, and retrofits to the power sector. So these are the focus areas. But after 2030, more than 1/3 of the growth in CO2 capture is indeed in heavy industry. And here you can see that in the yellow shading, where we show both the industrial process emissions, but also combustion emissions. And over the period to 2050, there's a growing role also for carbon removal technologies. So bioenergy with CCUS and also direct air capture, as I mentioned. And combined, we see around 2.4 billion tonnes being captured from these two applications by 2050. Around 1.9 gigatons of this is for carbon removal, where the CO2 is permanently stored, with the remaining 500 million tonnes primarily being used to produce synthetic fuels for the aviation sector. So there is a role also for CO2 use in this pathway. Moving particularly to the role of CCUS in industry, which is the focus of this panel session, this is an area really where CCUS is uniquely positioned to contribute to very deep emissions reductions. Heavy industry today is around 20% of global CO2 emissions, and as many will appreciate, it's one of the most challenging sectors to decarbonise. And there's really three key reasons for this. First, reflects the scale and the relatively young age of existing facilities. So much like power sector assets, many of today's steel, cement, chemicals plants have only recently been built, in the last 2 decades or so. And retrofitting CCUS is really an important solution to enable these facilities to continue to operate, but in line with climate objectives. Secondly, many sectors, and particularly iron and steel, really rely today on fossil fuels for high temperature heat. And there are a few alternatives today to providing that heat. And finally, around 1/4 of the emissions associated with heavy industry are actually process emissions. So these are not associated with fossil fuel use. They're a result of chemical or physical reactions. And so they can't be avoided through fuel switching, for example. And here again, this is where CCUS can play a really important role, and particularly in the cement sector, which I know we'll talk more about today. So on this slide, I just wanted to share with you that CCUS also can be a relatively mature and cost competitive option for heavy industry. I won't go into too much detail, but just to highlight that the CCUS-based process routes here that are in the yellow are relatively competitive across cement, steel, and chemicals to the alternative, largely hydrogen-based approaches, which are shown in purple. Now, for cement, because of the lack of other alternatives, CO2 capture is identified as the primary alternative pathway to conventional routes. So finally, achieving a net zero pathway will really require average annual investments in clean energy to triple to around $5 trillion a year by 2030. I just want to emphasize that it's really critical that this funding and financing and investment finds its way to the countries and the sectors where it's most needed. Just to highlight, this includes emerging economies. So we've just released a report on financing clean energy transitions in emerging economies, where we do highlight that today EMDEs, as we would say, account for around 2/3 of the world's population, but currently only around 1/5 of investment in clean energy. So for CCUS, the scale up in investment is significant, in line with the capture growth rates that we saw earlier. So in our sustainable development scenario, this scenario achieves net zero by 2070. Investment would increase to an average of more than 50 billion by 2030. That's from around 1 billion or so on average today per year. So the investment is broadly equally split between power generation and the industry sector, including fuel transformation. And more than half of the investment is in advanced economies, with China also seeing significant investment. For a net zero 2050 pathway, consistent with our recent report, the average annual investment in CCUS would need to increase to almost $80 billion a year in the period to 2030. So clearly this will require improved access to all sources of financing. So that would include debt financing, green bonds, as well as increased support from climate and development finance institutions, including organisations like the ADB, which have already been very, very active and supportive of CCUS in the Asian region. So I'll look forward to discussing some of these issues later in the session. So thank you, Juho.
Many thanks, Sam, for those insights. And $80 billion per year investment figure. I'm sure we're going to come back to that, and we also have some interesting finance sector talk after this. So I think we will be able to discuss this and how to make that happen. So thanks, Samantha. And next we're going to move to Yamnique Bjerkas, who is from Fortum Oslo Varme. And Yamnique will talk to us about waste to energy and CCUS and their project that they're currently working towards in Oslo. So Yamnique, please.
Thank you very much, Juho. And will you be sharing my slides? Okay. So hello, everyone. My name is Yamnique Bjerkas, and I'm the head of the carbon capture project that we are aiming to establish on our waste to energy plant in Oslo, Norway. Thanks. There I can see them. I hope you can see my slides as well. Next slide, please. A little bit more about Fortum Oslo Varme, which is a district heating company in Oslo. We are providing district heating for large buildings in Oslo, and the main heat load into this district heating system is the waste heat from our residual waste incineration plant. Fortum Oslo Varme has two owners. One owner is Fortum, which is an international energy company based in Finland, but with operations in large parts of Europe, producing energy and also providing waste recycling energy and circular solutions for sustainable cities. Our other owner is the city of Oslo. And the city of Oslo, as many other cities, has very clear climate goals with an aim to reduce emissions by 95% within 2030. And as this waste to energy plant is actually the largest emission point in Oslo, this carbon capture project will be essential to reach the climate goals for the city. Next slide, please. Our carbon capture project is a part of a full value chain of CCS, carbon capture and storage in Norway, named Longship. Longship just reached its final investment decision with the Norwegian state, with the state deciding to fully fund the full value chain with one carbon capture project and the transport and storage chain of the project. Unfortunately, this was not our carbon capture project. I will get back to that. But they fully funded the cement factory and the carbon capture project at their plant, which means that there will be a full CCS infrastructure in Norway for also for other emission points in Europe to connect to this open value chain. What we will do in this value chain is to capture CO2 from two different carbon capture plants and different emission points, one of them being Norcem with their cement plant, the other one being our waste to energy plant. In the final investment decision of the Norwegian state, we received 50% of the funding that we need, which means that we will have to establish the remaining funding from external sources before we are ready to go. But this carbon capture, this CCS chain will be operating from summer 2024. The CO2 will be liquefied at site and then sent off to an intermediate storage using vessels. From the intermediate storage off the western coast of Norway, the CO2 will be injected into a permanent geological reservoir using pipelines. And this is about 3,000 meters below seabed. So this is very stable and secure and permanent storage. Norway has substantial experience with the storing of CO2, as we have been doing it for about 25 years, stripping CO2 from gas production and storing it directly. So this has proven to be a very stable, very effective, and secure solution for removing and depositing CO2. And this new CCS chain, the new angle with this project compared to the earlier ones is that we are now focusing on industrial emissions to reduce emissions on industries and sectors that don't really have any other options for reducing their emissions. Next slide, please. So a little bit more detail about our capture project. We are aiming to be the world's first full-scale CCS project on a waste-to-energy plant. Our waste-to-energy plant emits about a little bit more than 400,000 tons of CO2 per year, and we're aiming to capture 90% of the total emissions. We are fully matured through feasibility, concept, and FEED studies, and we have also been quality assured from the Norwegian state, which means that we are shovel ready to go as soon as we have the financing in place. And we're aiming to have the financing in place by the end of 2021. As our plant is not situated at port, we will need to transport the CO2 from our plant to port, and we're planning to do that using emission-free trucks, preferably electric trucks. Norway is quite far ahead on the electric vehicle market, and we are quite confident that this will be in place and feasible by the time our plant is in operation. We have also tested the specific technology that we have chosen. We have chosen amine technology, which is per today the most mature capture technology and has also been proven full scale. We still decided to test the technology on our specific flue gas to learn as much as possible and to make sure that the process would work and that it would be safe. So we tested for about 5,000 hours and with very good results, low emissions, high capture rate, and stable operations. So we are very confident that this will be replicated in the full-scale plant. Now, the specific thing about waste to energy, which is quite important when it comes to climate abatement, is the fact that about 50% of the emissions from waste to energy or from waste incineration is actually biological CO2, because we are burning part biomass. And this means that when we're capturing and storing this biological CO2, we are in effect removing CO2 from the atmosphere. And this is a large contributor to the global climate goals to reach the net zero goal. Next slide, please. And the reason why this project is a part of the Norwegian CCS full-scale project Longship is that waste is one of the biggest climate challenges in the world today, and that we will need to see a large increase in the number of waste to energy plants in order to handle the actual residual waste that we cannot or should not recycle or keep in the cycle. More than 2 billion tons of waste is produced every year globally, and 5% of global emissions is actually only from handling the household waste. Most of it is methane emissions from landfills, which is the main contributor to global emissions from waste handling. So this is something that we will have to address in the years to come. We will need to move away from landfills and to move the waste up the waste hierarchy. And this includes, of course, sorting and recycling of the waste that we and the fractions that we want to keep in the cycle and to keep the raw material in the circular economy. But we also need sustainable solutions for the residual waste, the actual residual waste that is not possible to recycle. And by capturing CO2 from this end-of-line solution, we are able to not only decarbonize this waste treatment, but actually go carbon negative, because we are capturing biological CO2 as well. We can also imagine that in the future, building new greenfield waste-to-energy plants, the CO2 capture process can be integrated into the flue gas cleaning. So this is an interesting development that we need to work with the waste-to-energy technology technology providers to develop. Next, please. So this is how we need the future waste handling and circular economy to look like. We need to have solutions in place to keep the raw materials in the cycle, which means that we need to work with the way products are being designed and produced. And we also need to work with the sorting technology and the market for recycled goods. But at the end, some of the waste is going to be taken out of the cycle, and then we need waste-to-energy plants, which can both provide energy in the form of either district heating or electricity or both. And then by adding carbon capture and storage or utilization at the end-of-line solution. So we need to cut the stream of waste from this cycle to the landfills to reduce the methane emissions in the first place. By storing this CO2, we will take CO2 out of the natural CO2 cycle, going carbon negative, and we will reduce the amount of CO2 in the atmosphere. Next slide, please. If we look at the plastics in particular, which is the main source of CO2 emissions from waste incineration, more than 6 billion tons of plastic waste has been produced, and that's until 2015. So it's even more today. And if you keep in mind how little a plastics product actually weigh, 6 billion tons is just enormous amounts, which we can also see on these pictures. And we know that only 9% of these plastics has actually been recycled. 79% ends up in landfills or dumps or in the ocean, with huge microplastics and pollution issues to follow. And if we don't change this path, this will double by 2050. So this is really an issue that we need to address. We need to recycle as much as possible, and we need to capture the CO2 from burning the plastics for the end solution. Next slide, please. Looking a little bit more into the BECCS, or the bioenergy CCS, as is the whole name of it, what we also call carbon removal. If you look at the figure to the right, the upper right figure shows the natural CO2 cycle, with biomass being decomposed or burned, and the CO2 being released back into the atmosphere and then absorbed again from the growing biomass. So this is a natural cycle that is ongoing. The problem is, of course, all the CO2 that we're adding to the cycle using fossil energy. If you look at the lower figure, by capturing the CO2 from this industrial process, we are not releasing the natural CO2 back into the atmosphere, but we're storing it. And that's what we need to do in order to go actually below zero, to abate for the emissions that we don't manage to reduce in that time. So this is an important contributor to the net zero goal, that we actually capture also the biological CO2. This is a challenge because today we don't, the natural CO2 emissions are of course not counted in any CO2 budgets or climate budgets. And it doesn't either have a value when you're actually capturing or dealing with it. So we need to establish a system for certification and a value for capturing this biological CO2 in order to contribute to financing the capture processes. So next slide, please. And I think that will be my last slide. So to sum up, I think the main takeaways from this, from my presentation, is that waste to energy or waste incineration is not an opposite to sorting and recycling the waste, but it's an addition to, and it's also a necessary contributor to the circular economy. Waste incineration and waste to energy, adding CCS to this industry can contribute to large negative emissions or carbon removals, which will be important to reach the global climate goals. And it's also important for cities to reach their climate goals and to deal with probably the largest emission points of the cities with these waste to energy plants. And this will be an important factor also connected to the city's infrastructure and sustainable waste management. Thank you very much, Juho.
Excellent. Thank you, Yamnique, for that overview of the Fortum Oslo project and more widely on waste to energy, which certainly is a rising topic and important in Europe, but also in Asia. And we'll get back to some questions after we've finished with the first set of speakers. So thank you, Yamnique. And we move right then next to Beth Valiaho from the International CCS Knowledge Center, who will discuss their views on CCUS, and in particular their work that they've been doing with some industrial sectors, namely cement and some projects there. So Beth, please, the floor will be yours.
Thanks, Juho. You can just move to the next slide. Yeah. So first of all, I just want to say the Knowledge Center is actually comprised of employees and engineers in particular that helped to build the Boundary Dam carbon capture and storage facility in Saskatchewan, Canada. It has the capacity to capture 1 million tons a year, so 90% of the emissions off of a coal-fired power plant, and has captured over 4 million tons to date. And it's the world's first on large-scale post-combustion CCS facility on coal, and actually currently the only large-scale facility operating on power in the world. So we have a lot of lessons learned from that, and I've spoke to the ACEF in the past about that project, and happy to answer questions about that as well. But today I'm going to speak about industrial emissions as well. Before I do, I want to talk about how costs come down through iterations as well. And so the cost of carbon capture is often seen as a barrier, which is also why we do have, the financiers and different banks and governments, et cetera, all playing in this space right now as we try and get to net zero. I guess our tagline lately has been, you can't get to net zero starting from ground zero. And we were actually fortunate to work with the Fortum Oslo plant and talk with them as they started to look at their project as well. And we're always happy to meet and speak with people that are looking to go on the CCS journey, I would call it. I think some of the key findings when we applied lessons learned from the Boundary Dam facility, we decided to go just 12 kilometers down the road. And what we found at a facility, a coal plant, double the size, is that if we were to capture 2 million tons a year, based on lessons learned and economies of scale and other things, that capital cost would be 67% less per ton of CO2. So this is a significant step change in how we can just apply those lessons and make sure each of these projects isn't starting from scratch. Each case is going to be unique. Everything is going to be different. CO2 concentrations and those particulates and different gunk, if you will, that is in the emission is going to all impact how the carbon capture and storage facility works. But nevertheless, we're taking those lessons and going beyond coal as well to apply it to the industrial sector. Juho, can you go to the next slide, please? So the Knowledge Center has had the fortunate opportunity to again work in Canada. We are not limited to Canada, I will say that. We do a lot of work around the world, but we have an amazing opportunity partnering with Heidelberg Cement's subsidiary company, Lehigh, to retrofit a cement plant with a full-scale post-combustion amine-based CO2 capture system, looking to capture about 780,000 tons of CO2 annually. And we started a feasibility study. Again, there are many in-depth engineering design studies that go into these processes as we were told about the Oslo project, of course, they've done their feasibility, they've done their front-end engineering design studies, and they can't be shovel ready really until they have a lot of that certainty for final investment decisions. And so the feasibility study for the Lehigh project is actually going to be finalized this fall. So look for us at COP, because we'll be presenting those results there. But we are anticipating that operation for this plant in the mid-2020s. So likely by 2026, you'll see this facility actually capturing carbon dioxide. And so what's really important, and as you heard Sam mention, in cement, there are two streams of emissions that occur, and those are energy emissions and those industrial process emissions Sam talked about. So, you know, energy emissions, we can look at efficiency and all of those other things, but those industrial process emissions are really important to be captured and targeted with carbon capture and storage to significantly lower the emissions. And they actually represent 4% of global emissions, industrial process emissions. So this is a very important technology. And we're really looking forward to actually seeing how we can take those lessons learned directly from coal, applying them to cement, and figuring out how we can apply them even beyond to other sectors as well moving forward. Next slide, please. So, you know, a little bit about cement manufacturing. And so, you know, we know cement and concrete, maybe we use the words interchangeably a lot of times, but cement is used to make concrete. And it's the second most consumed material in the world. And it's the most consumed man-made material. And it's not going anywhere anytime soon. It also uses a lot of water, let's not forget. But what's really interesting is that, you know, global cement production has 4 billion tons of CO2, of cement production, sorry, a year. And that's about almost 8% of global emissions. And so the International Energy Agency, Sam's organization, says that demand is expected to increase even more. And as we see developing countries start to become more developed, you're going to see, you know, more iron and steel, more cement. These are not the industries that are going to be transitioned away in anytime soon. And so they're going to be targeted to for CCS, hopefully, and how we can reduce those emissions. Again, as Sam's organization has pointed out in their sustainable development scenario, we need about 450 million tons of CO2 to be captured by 2030 by all of industry worldwide, and mainly by the cement sector. And we need to have about 60% of the emissions from cement being reduced by CCUS. Next slide, please, Juho. So again, I love all of the IEA's work. We refer to it quite frequently in the work that we do, because it really is great work that makes the case for why CCS is required, and we hope that we can tag team along that to say why lessons learned on CCS are important to be shared. But in any case, why those lessons are important when it comes from coal to cement in particular is that the flue gas is very similar in cement to coal. And you know, this is a technology that's been proven, and so you can apply it to existing facilities as well. You don't need, this doesn't need to be new facilities. The Boundary Dam facility, for instance, was a retrofit of a coal plant that was nearing its end of useful life. And of course, it actually has emissions cleaner than natural gas. So it's a very positive, you know, move forward. And so for cement, what you're looking to capture is the emissions after being generated in the cement kiln. And there's no fundamental modifications that actually have to happen to the kiln in order to do that. So the other piece, and touching on the Fortum Oslo Varme project again, there is biomass that can be burned in that 1/3 of emissions that are the energy emissions, and you can result in carbon neutral cement. And you're seeing that out of the Heidelberg facility in Sweden that's looking to have a CCS facility by the end of the decade. Next slide, please. Oh, that's my last slide. I kept it short for you, Juho. I know we were touching up on time there, so happy to answer any more questions.
Wonderful. Thank you very much, Beth. What I'm going to do is I'm going to stop the slide share, the screen share here, and kindly ask the speakers of our first section to switch on their cameras, and we can take a couple of questions here in the next few minutes before we go to the financing part. And to everybody in the audience, our speakers have all promised to stay until the end. So when we have our next second section for Q&A, we can also direct questions to people for all our speakers. But let's just do at least one per speaker at this time. And starting with you, Ian. I saw also, but you answered a few of the questions that came through the Q&A function. So thanks a lot for that. And but in your last slide, you were kind of looking into next steps and what would happen after this global surge of hubs. Can you go a little bit back and briefly discuss, what do you think needs to happen next to start making these hubs actual reality?
Sure. So one aspect we haven't really dived into is where the hubs are, in particular in various countries in Southeast Asia. And for that, our next action really is in a couple of weeks to be doing that with the governments through the CEM and really having that level discussion about the real deep dive into where these hubs are in Southeast Asia. And I managed to misanswer one of the questions. I think I pressed the wrong button and it just disappeared, the question. So they're asking about how many hubs there were as tier 1. And globally, we're looking at about 23 hubs for tier 1 spread around the world. And that was a really interesting part about the study, that these hubs weren't all located in one particular geography. They were spread throughout the world and accounted for around about 100 million tons. Because when we look at these preferred scale hubs, we're looking at the sort of what would be the best industries within our bigger hub to kick that hub off and actually allow that to sort of snowball. So just to answer that question, I sort of managed to delete somehow. But yeah, so going back to your question, Juho, sorry. Apart from this meeting we're going to have in a couple of weeks with the CEM invitees, what we want to do is also we've been developing white papers to look at commercialization roadmaps for CCS in countries. We've already done Saudi, and we've done China. That'll be released in the next few months. But then we want to expand that to other countries that are also of the higher profile countries in our analysis that really demonstrate that they have real potential to have CCS rolled out quickly and effectively and at scale. So we want to sort of focus on those countries in the next little while to get some white papers for them. We also want to develop our knowledge platform. So really develop a lot of how do we actually set up hubs? What the lessons learned we've had from the various hubs that we have within OGCI, and how can governments and other emitters potentially develop that. Someone's showing us their emails, which is very interesting, but I don't think we need to see all the emails right now. Another aspect we're looking at is Article 6 and how can we get credit trading globally going. So we know that Article 6 is very important and will be deployed potentially for CCS, hopefully signed up in the next COP. But then what are the mechanisms behind the international trading of CCS derived credits? So we really want to sort of dive into that aspect, and that will allow some global flow of sort of money and the financing to help these CCS projects, particularly in Southeast Asia. And finally, the Asian CCS network that people aren't aware of, they need to sort of Google and find out more about. OGCI will certainly be looking to facilitate and help where it can this sort of Japanese-driven initiative, which looks very good, specifically for the Southeast Asia.
Great. Thanks, Ian. I think it all goes to show how important it is that you have industry and governments and the finance sector actually all working together to make these hubs and projects happen. Samantha, you obviously are doing a lot of scenarios at the IEA. Industrial CCUS is a big deal within CCUS and for the global climate change mitigation. Have you got particular views or thoughts as to where the most optimal sectors and regions might be found to get some projects started?
Sure. So thanks, Juho. I think in terms of like early opportunities for CCUS, we do have some lower cost opportunities typically associated with high purity CO2 streams. So that could be related to things like natural gas processing, bioethanol production, but particularly low carbon hydrogen production, or blue hydrogen as it's often called. So I think there is certainly some opportunities around these types of industrial applications. Also really, the sectors such as cement, which Beth just highlighted, where there's few alternatives or no alternatives to CCUS. So these are really critical applications. And so the drive and the need to be deploying CCUS in this sector is arguably greater. But in terms of sort of the optimal and earliest opportunities overall, I think the answer to that's probably contained in Ian's presentation. Really looking, I think there's a very important geographical element to this, where projects will be deployed, where there's infrastructure, where industrial clusters can be identified. We're already seeing in Europe the availability of projects such as the Northern Lights storage facility is prompting a lot of interest in capture projects. Equally in the US, where there's existing pipeline infrastructure, projects are seeking to tap into that. So I think the availability of that transport and storage infrastructure, and then the second really key defining feature, I think, or driver, will be just the investment environment. And again, Ian already pointed out, we're seeing a lot of activity in the US, a lot of activity in Europe, and that's because there are incentives in place to invest.
Great. Thanks, Sam. I think what's really nice about the CCUS space at the moment actually is that we're getting into a much more practical discussion on how we make things happen. And I think that's really a major change from a number of years back when discussion was much more on the principle of whether we should do this or not. Yamnique, the Fortum Oslo Varme project. You said you're looking to do the world's first waste to energy CCUS project, and that's brilliant. Can you comment whether there are other companies trying to do the same? Are you alone, or is there a good movement in the waste to energy sector as well as regards CCUS?
Well, I would say that when we started back in 2015, we were quite alone. And I'm sure Beth can also confirm that that was the first time they were looking into waste to energy as a possible CCS sector. But during these years, this has changed substantially. And we now see large interest in the sector for this technology and for the learning from our case. Especially in Scandinavia, where we have a lot, we do not landfill our waste at all. So this means that we have quite a few waste to energy plants already. And these plants are very much interested. They see that this is the development that is coming. This has started already. It's not possible to stop it. And I think most plants are now very eager to get started and to be a part of this development. So all large plants in Scandinavia, I would say, are more or less started on their studies on the CCUS. We also see the development further down in Europe, especially in Switzerland, in the Netherlands, in the UK. But this is slowly spreading out throughout Europe. And I'm sure that this will be a desired development also for Asia. But of course, the main step when it comes to waste handling will be to look into how to close down landfills and start the development from there, establishing waste to energy, establishing sorting and recycling, and then of course, hopefully Asia can learn or can take the learnings from the cases in Europe, so that the project in Asia can in due time be developed much easier, faster, and cheaper than the first ones in Europe. So this will be a learning curve to reduce costs and to increase the efficiency of these plants.
Great, thanks, Yamnique. And also what Samantha was mentioning there a moment ago about infrastructure, I think that's also a critical point for especially the waste to energy plants in different parts of cities, taking advantage of inland waterways, for example, in Europe, potentially to transport CO2 to storage sites and so forth. So,
absolutely.
Thank you for that. And Finally, Beth, you spoke about cement, but what about the other big sector, which is the steel sector? Have you done work with them? Can you highlight a few interesting insights into CCUS with steel?
Sure, yeah, my pleasure. Well, as you may be aware, one of our founders is BHP Billiton, who actually mine metallurgical coal that goes into steel. So we've actually done a lot of looking around the surface on this. I mean, when we talk to the World Steel Association about CCUS, of course, they say safety has been the #1 focus, the #1 issue that they've looked at. And but a growing list of the world's steel manufacturers have made commitments to net zero emissions by 2050, and that means CCS is going to have to be a part of the equation. Currently, CO2 emissions from steel manufacturing, it's almost double the amount of steel created. So 1.87 roughly tons of carbon per 1 ton of steel. And 50% of that is produced in China, I might add. Steel and iron production is reliant on coal, and both as a feedstock and often as a fuel. And unlike cement emissions, which I talked about, the emissions arise at different points in the steel production process. So you need to focus on different parts. There's also blast furnaces or electric arc furnaces and all different things that you have to consider. And given the urgency of the need for those emission reductions, the very different characteristics of the flue gases and all of that CO2 that's involved, we're going to need a portfolio, I think, of capture technologies to deliver this a minimum cost and energy consumption. So I think that the steel industry could meet the challenges and make CCUS an important part of their transition to a sustainable future. But they're definitely going to, I think, need to use transferable knowledge and know-how, looking across different technical applications and having some piloting scales to start.
And know-how and skills that your organization, amongst others, will be able to offer, I'm sure. Wonderful. So thank you to our first speakers of the event, and let's now move to the second part, which is more around financing of CCUS. And we've got two interesting speakers for you in this section. We have Mark Sisoda Silva from ING, and we have Ed Morse from Citi. And if I could ask both of you, gentlemen, to give roughly 10 minutes reflections from your side. Mark, I have your slides, and Ed, you will share screen from your side. And then we come back again, everybody, to a final Q&A session to finish off with the program. But I will start share here again and give the floor to you, Mark, for your part of the presentation.
Okay, that's great. Thanks a lot, Joe. And yeah, it was very interesting to watch the presentation from the previous speakers. Very good to see all these fantastic projects going on. Yeah, from my side, I'd like to explain a little bit about how we look as a financial institution to the CCS. And first of all, I wanted to show you a couple of slides to create the boundaries how we are involved as a bank in this. And then I like to discuss a couple of details of projects where we were involved with, and so that you can have a look at how we as a bank look at it. And Ed will obviously comment to that as well. Yeah, the first slide, Joe, if you can take that. ING is basically a global leading energy bank, and on the left-hand side, this is more European examples, but we are involved basically on a global basis in upstream, so oil and gas, and financing midstream, also say drilling and transportation, and also production of electricity. And that is basically the whole value chain that we look at. So the electricity part is mainly solar and wind, quite a lot. But obviously upstream is there as well. So after the Paris Agreement in 2015, we have done a lot of work. We started with a scenario planning exercise to look at what will be the demand of oil and gas in the future and how would things change because of this agreement. And then we have then, in 2018, we started to cooperate with a small firm, which was called 2 Degrees Initiative, to see how we could basically align our lending portfolio to the Paris goals of a maximum 2-degree global warming. And 1 year later, in 2018, we agreed with a couple of other banks. You see them on the right hand, also with BNP, SocGen, Standard Chartered, and BBVA, to work together on a so-called Terra approach, which was sort of started a little bit earlier by us. And that is a very scientific way to review our portfolios and to make sure that it is aligned with 2-degree initiative. So it's a lot of detail in it, but that is in short how we started with that. Next slide, Joe, if you can. Yeah, and this is just it's a very wide slide, a lot of detail. You don't need to look at the detail, but the idea of this slide is that we also started in 2015 already with green bonds, and we are quite, say, one of the leading banks and thought leaders in the green bond market. We did around more than 90 bonds at the end of 2009, so it's a bit more now. And that is a market that is growing big. And this is just to show you that for us, it is a really important element for us as well. Next slide, Joe. Yeah, and after that, so let's say last year, we thought we need to do something with the new technology. So we have formed 3 expert groups within our bank, and that is what we called new energy technologies. We define basically hydrogen, carbon capture, utilization and storage, so CCSU, and energy storage. We think that those 3 new technologies are very important for the whole energy transition going forward. So for all these 3 groups, we have developed a center of excellence with people in our global offices, and a technical team support those 3 groups. So for CCUS, we have now a dedicated working group. We have an in-house technical team with 3 reservoir engineers, and where we focus a lot on upstream, but also the subsurface risk mainly. And we have a large energy project advisory group. And that is one of the largest groups in the banking world. And that is very helpful for clients when they start defining their projects. And that is how we brought it all together. It's pretty new. I think we started the beginning of 2020, and now all these centers of excellence are in place. And we are really making a lot of effort now with clients in the CCUS market. Next slide, please, Johan. Thanks a lot. So this is just a couple of projects, but you have heard as well from Yamnique that there's in Norway, obviously, one of the largest projects going on as well with Longship. But here in the, let's say, UK, Netherlands, and Denmark, we see the Portos project, for example, coming, Ethos project, it's also in the Netherlands. Acorn project with Blue Dot and Shell, Total and Harbour, and the Green Sense in Denmark. So these are just a shot of it, but there's many more of projects and clients that we are at the moment talking to see how these projects could be made bankable. And the next project slide, Johan, please. This is a Portos project. That's the first one that we worked on, and it basically the project sponsors asked us to do a bankability study, and that is quite important because if you are at an early stage, you can already talk with financial markets and financial institutions to see what you need to make it bankable. So this project is the largest project in the Netherlands. It is basically planned in the harbor of Rotterdam area. They are the sponsors as well, together with EBN, that's the Dutch state, and GasUnie, which is the biggest owner of pipelines in the Netherlands. And this is a real important strategic project for the Dutch state. And what is also important is that the European Parliament has approved the project with a status that as a project of common interest. And that is also a very important thing to remember, that that the support from the governments is really key. In the Netherlands, we have a subsidy scheme, which is called SDE++. You can forget the name, but that's the important one for the Dutch clients. And that has basically a couple of weeks ago been granted to this project. So we expect that FID, so the final investment decision, will be taken later this year for this project. So we were a financial advisor, and yeah, obviously, hopefully the project will be financed as well at a later stage. So next slide, please, Juho. Yeah, if you look then at basically the technical aspects of a CCU project as we look at it, yeah, you can say you look at the carbon capture side, the transportation side, and the storage side. If you first look at the carbon capture side, you see that there are some potential risk, and the previous speakers talked already a little bit about it, about the amino absorption technology. It's basically the most mature technology, and we expect it will be mostly used for the projects. But there is not so many large-scale plants, but you as you have heard also from Yamnique, the pilot plant at their site was very successful. So we expect that this will be used very often. And what we also saw in the previous speakers is that when you have a large-scale development deployment, it will also reduce in cost. We don't expect real big step changes, but basically you could expect step changes there. And if you look then at the transport, it is, well, potential risks are the pressures, of course, but there are pretty high pressures, but you see 1,000 to 2,000 PSI. But yeah, obviously we are quite used to that in the oil and gas industry, for example. So that's not really something that is not overcomable. Impurities is something to consider in these big pipelines, corrosion and downhole problems, but that is all things that are able to be managed by good parties. And then the last part, the storage side part, is maybe the most important one. So subsurface uncertainties, you have to contain it. There are reservoir characteristics in the oil and gas reservoirs, for example. Leakages is important, induced seismicity, so earthquakes, that is all things that you need to monitor, to check, to review, and that is the things that we also focus on as a technical team within the whole banking structure, to see if that is mitigated to a certain extent, or say to the largest extent. And mostly important, I think, for example, oil and gas companies, and we have seen it with Ian's discussion for OGCI, oil and gas companies obviously are in a very good position because they have infrastructure, they have the capabilities, they have access to the oil and gas fields, in-house expertise and operational capabilities. So these are logical players to take these big and a bit complicated projects on. So that's sort of the general view. We don't think there are unovercomable technical challenges. There are challenges, but they're all within the range that can be banked from a financial point of view. Next slide, Joe, please. So if you look at the key lessons learned, that we looked at some other projects, is 4 important points. So cash flow is important, experienced partners, as I earlier discussed, robust contractual structures are important, and you need to plan ahead for due diligence if you want to finance it. And so the cash flow, I already touched it. It is very important that there is a revenue stream. So in fact, most of the time that is a subsidy part in there. And usually the emitters, they get the subsidies. You need a good supply or pay contract. It should be based on availability and not based on when they get the CO2. So that's important to make it bankable. Tariff payments are important, but you have to isolate it from market or utilization risk. So it is really important that there's a continuous flow, like in a infrastructure finance, continuous flow of tariffs. And obviously that should cost the OPEX, operational cost, but also a return on capital. Second one, experienced partners. That's why we also address these oil majors, or at least partners with significant experience. They should be involved. And it is very important that all sponsors, emitters that provide the CO2, and also other key project parties, like for example EPC contractors, that they all aligned. That is also important when want to be able to get easy finance at a later stage. Third part here is contractual structures. Well, there we talk more about EPC contracting, completion support from sponsors, test regimes, interface management between, for example, onshore and offshore parts, liability definitions between who operates the pipelines, and the injection and the storage, and obviously measuring and monitoring of the CO2 once it is in the ground is also pretty important. And the last part is a simple one. You need some third-party due diligence for all parts of the projects, and you have to think about that ahead before you start to make it easier again to finance it. Thanks, Joe. Next slide, please. So if you look at the potential forms of finance, you could see a couple of them. You see pre-completion, it is a bit limited. Obviously, if you do a corporate debt financing on a corporate debt level of a sponsor, you could do that relatively easy, depending on the credit state of the sponsor. But if you want to finance it with non-recourse or limited recourse, it is the most easy post-completion, so once the plant has been built. But also with a project finance, for example, which is limited recourse to the sponsors, you could also do that before project completion. But then you need some tests, you need some completion guarantees or partial completion guarantees or standby equity. So there's a lot of detail that you can think of, but there are a lot of opportunities there. But so project finance before, but after project completion, you can also look at debt capital markets. So private placements or project bonds, for example. And that is, there's quite a good market for that. So the European private placements, that is Asian and EU institutional investors and banks. US private placements, it's mainly insurance companies, and the project bonds, that is basically the US and EU insurance companies and asset managers. So it's quite a big range of investors that are quite interested in these type of projects, and obviously mainly after completion, because then they know that the project runs. Banks can do it even before, but then you need a lot of bells and whistles in the structure. And planning ahead is key. So planning ahead, before you put all these contracts in place, it's very good that you think of that before. And that's nice to talk with a bank, for example. Next, please, Joel. Yeah, so this is just an overview of, as we see, let's say, institutions and banks that are quite interested probably in good projects. So that's quite a big horizon, and ING is one of the leading banks that would be involved in this as well. Okay, the last slide I like to show you is the green side. The EU taxonomy, and you and myself, we talked a lot about it. It's not an easy paper to read. There is an update on that, but we are now quite certain that CCS is now a key technology for decarbonization of Europe. Basically, if you look at the left-hand column, you see that what we show there, it is a key technology, and it is without CO2 transportation and storage and infrastructure, Europe will not achieve its climate objectives. So it is really recognized now within the EU taxonomy that CCS is part of that, and at least as a green buy or green off activity. So that is a good point. And for the green bond principle, so it's more from the banking side, the International Capital Markets Association is sort of defining the rules for green bonds, and therefore it is very important to see where are the proceeds of the bank finance used for. And if you look at the middle column on the bottom, it indicates like pollution prevention and control is eligible as a project category for that. And carbon sequestration has been used successfully. For example, in an Apple, one of the Apple's green bonds, they could use the funds for carbon sequestration. So basically carbon capture and storage. So it's a very good point that could also be used, green bonds. And then there's a third institute, the Climate Bond Initiative. It's like an NGO, non-profit organization, and they provide certification for any type of initiative that meets the 2-degree global warming goal. And there, that's also indicated that CCS itself is eligible under the so-called pollution control and non-energy greenhouse gas reductions. So it is really good that CCS is also recognized now by EU taxonomy, green bond, and that really increases the global source of funding for these projects, and we are very happy with that. So yeah, that's sort of short that I like to explain to you from our side. Thanks, you.
Thank you very much, Mark. I think this is great insights into how a bank thinks about CCUS, and it's very, very good to see that you actually think quite positively about it and seem to be willing to play in this, provided that you see good projects coming to you. Mm-hmm. So excellent. Thank you very much. And next up then is Ed Morse from Citi. And I'm going to stop share here again, and we're going to let Ed start without slides. And we had a bit of a difficulty getting Ed's slides to me, but I am now going to go and look for them. But in the meantime, Ed, you can go ahead without slides, and I'll bring them up as soon as I have them. So please go ahead. You are on mute, Ed.
Thanks very much, Juho, and I apologize for my double technological difficulties today. One was Citi's difficulty of getting things to the right person through the right email address, and then I'm remoting in. I'm using 2 computers in one, and I lost access to the other one because it timed out, so I can't share my screen. Anyway, following on Mark's excellent presentation, he noted particularly how much more difficult it is to get direct financing of CCUS projects than it is for other things. And I just like to point out that bank involvement in green energy has skyrocketed in the last 3 years. If we just go to 2019 and look at one of Mark's presentation slides on green bonds or sustainability bonds, there was about $250 billion worth in 2019. 2020, despite the pandemic, there was $552 billion worth, $500 billion. And this year we're already past, not halfway through the year, the 500 billion mark, so there'll be a trillion at least. And it's a kind of remarkable growth area, as are SPACs. Next slide, please. The problems that are confronting CCUS are twofold. If you can get to the slide, but they are the energy transition itself and the question of whether it can be managed without increasing the role of natural gas. We think it can't be, but there's plenty of talks among political leaders in various parts of the world. Europe is in the lead on this, on stopping bank lending, stopping bank involvement in a whole array of subjects that are very much energy transition involved, and that would include carbon capture and sequestration and utilization. The other real issue, and to me is the most critical one globally, is that I don't think banks will be deeply involved in project finance part of carbon captured sequestration unless there's really a good way, a good mechanism for pricing carbon. And at the moment, the only place in the world where there is a large economy that has a mechanism for pricing carbon is your European Union. Of the 3 large economies in the world, the European Union is in the lead with now something like a €50 price on carbon dioxide, and we forecast that price to get to 100 euros a ton by 2030. At 50 euros a ton, you can easily deal with competition against coal. You need 100 euros a ton to deal with where the state of technology currently is with carbon capture. In the next slide, we look at the good news on this, and that is that carbon management is a crucial part of decarbonization. It definitely needs a carbon price, and as we can see on the next slide, there are more and more places in the world that we find mechanisms to price in carbon 3 years ago, there were only some 20 places in the world that had anything like a carbon price. Europe again being in the lead. There are now more than 60 places in the world. That's a big jump, including the 3 largest economies in the world. So China has been added to the list, as has the US. China, by trying to mimic the ETS system in Europe, but is going at it in a very conservative way. So is planning to start the pricing level at around $25 a ton. The US is lagging in one sense. It's lagging in terms of reluctance to do anything related to a carbon tax, but it's in the lead in another sense, in the offering of an array of carbon credits through the tax system or through various mechanisms that exist in the US. As we can see on the next slide, it's not exactly going to be a continent-wide system, but we have selectivity of carbon prices around the world and within the US. California has 2 systems. It's got a cap and trade system, but that's pricing carbon at around $20 a ton. On the other hand, there's an offset arrangement through the low carbon fuel standard system, and that offset has already hit 200 a ton. It's about $180 a ton at the moment, and that facilitates a lot of new investments. But what we really need, as I say in the next slide, is a higher carbon price, which would really facilitate decarbonization investments and facilitate bank more direct involvement in marshaling capital. On the next slide, I note that pricing is critical to reducing and eliminating carbon. And it's not just the price, but as we see on the chart on the left, which is a kind of CCS cost curve, similar to the cost curves that others have presented to us this evening, we think there's a movement toward the left. That is, the cost curve is coming down. The cost curve is coming down for a variety of reasons, including the birth of new technologies. We've seen on my slide 7 the cost of CCS differing across industries, with cement being very high, natural gas combined cycle being high, but natural gas processing itself being at the lower end. And the costs are, as I show in the next slide, rising. The costs are lowering. They're continuing to fall over time and have from 2010 through 2020, and we think they'll continue to fall in that same direction, while carbon credit prices continue to rise. And now we are seeing an expansion potentially of carbon credit in the US market, which I'll talk to about in a moment. I'd like to drop down to a couple of slides to the significant investment opportunities into CCUS, and note that there are several countries that are making strides. Saudi Aramco and Saudi Arabia by itself, with the adoption of the circular carbon economy, the US Department of Energy authorization to spend $6.55 billion on R&D for CCUS over the next 4 years, and the critical issue of hubs, which we've talked about, and no doubt the use of hubs makes the mobilization of capital and bank involvement a lot easier. I have a summary of the hubs that we've all talked about, and all of the projects that Beth and Yamnique and Mark talked about are located on my slide 11, which looks at projects that have already entered final investment decision, including one that she mentioned on the Fordham Oslo Varme project, and others that are coming into targeted dates for final investment decision over the next 3 years. So the economics, as the next slide shows, works with the clusters and brings CCUS projects available. We have no problem in project financing, as I show in the next slide, for wind and solar. It's at the beginning of an extension to CCS, and I'll talk about that in a minute, as it is also beginning with respect to hydrogen. But in terms of carbon capture projects, project financing is way behind where the world is on wind and solar. I'd like to dwell a few more minutes on the next slide, which is very much part of the very politically contentious Biden infrastructure project plans. And I'd say that the sustainability infrastructure of what the Biden administration is proposing really would be susceptible to financing, more direct bank involvement in financing both storage and pipelines, and the two are interlinked. The Biden proposals are to extend tax credits in what we call 45Q in the tax code, which gives a direct credit for carbon capture projects. They want to expand this into the transportation system, so that we know that there is a significant cluster, for example, of CO2 availability, and including blue-made CO2 with carbon capture and sequestration on the US Gulf Coast. We know the storage facilities are not on the Gulf Coast, but are inland, as you can see on the left side of the map. The ability to finance pipelines are the basis of takeaway capacity, and the willingness of those with the storage capacity to take the storage, and the willingness of the seller to commit to a pipeline. So those are the elements when you have offtake arrangements that bring project finance into this realm. And we believe that this part of the Biden proposals will make it through the reconciliation process in the US Congress, and will provide the basis of pathways to carbon capture and sequestration. Very briefly, on the next slide, I, like everyone else, was asked to comment on multiple ways that Asian countries get involved in decarbonization, more broadly speaking. And it's not just through capture technology based on the things that we've talked about. Direct air capture is certainly seeing more investment in technology, including investment by private equity firms. We're seeing private equity firms involved in terrestrial and biological carbon capture. Some of us had mentioned BECCS earlier, but forestry is a popular item and is popular in the context of COP26. There's a lot of greenwashing. It's kind of false mechanisms that are misleading on the reforestation side, but there are mechanisms available for reforestation that do attract capital, that can be more secure than a lot of the greenwashing that's currently at stake. Finally, I'd like to note that green securitization is just beginning. On my final slide, we're seeing finally the bunching up of loans, and very much in the way that mortgage markets around the world have matured, by pooling mortgages and allowing investors, macro level investors, large scale investors, including pension funds, to take advantage of the upgrading of credit that you get from the pooling of loans. We believe that the securitization can be absolutely starting in sustainability bonds, And we have some hope that they will with respect to financing CCUS. So that's it. I went through 18 slides or 16 slides as rapidly as I could, and I'm happy to go into the next part of our discussion.
Thank you very much, Ed, for driving through your slides so efficiently and for all those insights, and indeed apologies to you and to the audience for a somewhat suboptimal viewing of these materials, but they will be available afterwards, so you can go back into them in more detail. So if the panelists could please switch on their cameras again, and we'll have a final section on with some questions. Kei Nam had to leave us earlier, but his colleague Jim Yao is with us. So if there's any aspects and issues that he wants to comment on from ADB's side, Jim Yao, you're very, very welcome to do so. Let's go through some questions. Last year, the SEM CCUS initiative, together with a bunch of finance institutions, issued a document called Key Financing Principles for CCUS. And this was a very brief and simple document with 10 high-level principles on how we might be able to speed up CCUS and financing of CCUS. And one of the principles was around risk mitigation. And essentially it said that governments, industry, and the finance sector should collaborate to find ways to mitigate risks to invest in CCUS projects. And it's a big area, of course, but we have project developers here, we have industry, we have folks who've been studying technology scenarios, and people from finance. So I think it's a perfect place to ask the question and ask everyone to comment a little bit on, well, what does collaboration for risk mitigation really mean to you in practice? And I'm going to just start the way I see you folks on my screen. I'm not sure if everybody sees you in the same order, but we're going to do Beth first. If you have any thoughts on this, please.
I sure do. I talk about this all the time, actually. And one of the things that the International CCS Knowledge Center really tries to help to de-risk investments is through our knowledge and lessons learned. And we think that we can partner with governments and financiers to ensure that there are stage gates and milestones along the way of a project, so that, in fact, they're experts who have actually done these projects can ensure that these projects are going to unroll effectively and efficiently. And so we see it all the time, you know, projects that have even gone into front-end engineering design stages whereby they don't meet final investment decisions, you know. And so you can try and de-risk by adding more government support. You know, in Canada, there's now going to be $170 carbon price by 2030. There's an investment tax credit that's been announced in the budget. And as well as offset credit opportunities for both enhanced oil recovery and storage in Alberta. But people still say it's the capital cost that is that barrier, though the operating costs are still, you know, there. And when we have multiple players coming into this space, we really need to try and figure out how we're going to have the most successful projects. So using proven technologies, using iterations, and those types of things, I think, are great ways to advance quicker. We're going to need R&D and everything as well, every tool in the toolbox. But I think the Knowledge Center can do a great job to work with financiers and governments and decision makers to de-risk through lessons learned.
Thank you. Next in my sequence is Mark. I think you had a very nice slide there with the sort of 4 key success areas that you need, which was cash flow and things like that. Perhaps that's part of it, but yeah, could you comment from your side what risk mitigation is really in practice?
Yeah, I think Matt's point were very good points, to work to cooperate and to learn from each other. That's fantastic, of course, very important, especially when things are now growing and starting up. I think that in short, I think we should do where we are best in. For example, the government should make sure and also look at each other and make sure that our tax credits or subsidies in place, or even CO2 pricing would be good on a more global scale, but that is difficult. But there are some leaders in like Norway that are just taking the step, and then others may follow. So that's one thing. And industry, I think they should also do what they're good in, and that is using their capabilities, their EPC contracting skills, mitigating the risks that other parties cannot take. And I think that the finance industry should, based on that the risks are mitigated that they cannot mitigate, they should really push project finance and bonds once that is also in place. So I think they can all do where they are good in, and because project finance has been there for a lot of projects already, that it can also be done for this. And I'm certain that and Ed indicated that it is in the early stage. I'm basically, there were no real project finances for CCUS as far as I know, but it will come, and I'm sure that we can make it work if we work together, and if we do where we are good in. So then we will find each other, I'm sure.
Thank you. Jin Miao, do you have any comments from the ADB side?
Thank you, Joe. I would like to introduce the mode of the ADBs on CCUS work, how to mitigate the risk for CCUS investment in a certain country. First of all, we will reach the DMC government, particularly CCUS policy makers, to introduce this technology to them. At the same time, we will identify and contact some important industries or enterprises who have an interest on CCUS projects. So then ADB will provide some fund support for the enterprise to do some feasibility project feasibility study and make some capacity building. If the potential project, the study result is positive, we will bring this project opportunity to ADB operational departments or other financial institutions to help them reach these players. So I think this is the very real and the practical of the ADB for CCUS investment. So far, ADB has no CCUS loan projects yet, and all the CCUS projects are grants. Thank you.
Thank you, Jin Miao. And also interesting to see that actually the risk mitigation is a very wide concept, and for a multilateral development organization, it actually is as much about capacity building and building a capacity within a country, and not just on project level. So that's an interesting point to note. Yamnique, I think risk mitigation and risk sharing has probably been on top of your agenda for several years now. So what is it for you?
Well, of course, the earlier speakers have mentioned a lot of important points. So I will try not to repeat all of them, but I think the learning from the project that have already been established is important, and also to specifically focus on the integration with the existing facility, which is for our part one of the main risks, because this hasn't been done before, and it's important not to disturb the production facility, either whether it's cement, steel, or waste to energy or whatever. So the interface between the, if I can call it, the production facility and the CCS plant is an important area to focus when it comes to risk mitigation. Of course, the whole project on our side has been developed in collaboration between the industry, the state, and also R&D players. So the risk has been high focus, especially on both on the technology side, but also on the financing side, of course, all parties looking to reduce their own risk. And that is maybe one of the main challenges, because we don't have any revenues. CO2 doesn't have a value. It's a waste product that we need to get rid of. So, and that's the challenge today, that it's too cheap to emit CO2, and the plants are still quite, it's early in the development, and it's costly. So I guess that's the biggest risk if you look at the overall CCUS area and the development, is that we need to see a more focused development, and to look into carbon pricing, but also pricing of the carbon removals to have these markets increase in value. I'll stop there. Thank you.
Thank you, Yamnique. Ian, what can OGCI do in risk mitigation, risk sharing space?
Thanks. So I think just to build on your comments earlier of the panel, I think particularly having a level playing field and understanding of the risk and appreciations of the risk is really critical, so that a regulator who may be more used to understanding the risks in a land-based electricity system will actually be able to understand what is the risks of putting CO2 subsurface and things like that. So really having that capacity building within the regulators and the finance industry, so they can adequately understand the risks, and then we can start with a level playing field. If we understand those risks, about the sort of benefits of the who takes on the more risk should be rewarded more, and benefits that way. So we have an understanding from that aspect of how those benefits can flow to those who can take on the larger risks within that value chain, wherever they may be, because there's very different risks in the entire value chain. So I think it is a case of understanding from a variety of places that these risks will come from the CCS project perspective, because this is quite a unique industry. And so very different to even the oil and gas, which is just producing the oil and then shipping it out and everything else. They're all quite fragmented in this value chain, where CCS here, we have this sort of full value chain that we are having to break up from the capture side to the transport side to the storage side, and that they're all very specialist domains of knowledge. And so having to combine that is quite difficult, and certainly OGCI will, and its member companies can certainly facilitate that aspect.
Thank you. Samantha, in IEA's work, policy work, strategy work, what thoughts do you have on risk mitigation, risk sharing?
Thanks, Juho. I agree really with a lot of what's already been said, and I really thought Mark and Ed's presentations were excellent, and I think really highlighted that the technology or technical risks are seen as manageable. So one of the key or important features is really ensuring that there's transparency and certainty around the investment environment, and particularly what the policy frameworks look like to support the investment. I think alongside that, investors need to have the confidence in the regulatory regime governing CO2 storage in particular, and how long-term ownership and stewardship of the CO2 will be managed. And I think this is an area where many countries do have regulatory regimes in place, but not all. And particularly, I think there's a task for working with countries to develop legal and regulatory regimes, including in Southeast Asia. And I think it's already been picked up, but the building the capacity and the know-how and the confidence in CCUS in regions that are perhaps not yet as familiar with the technology will be really critical.
Wonderful. Thanks for that, Samantha. Finally, Ed.
Yeah, I'm only going to repeat what I said at the very beginning of my presentation, that there were two issues that were critical. One is whether banks will be permitted to invest or to provide capital, either on a loan basis or some other basis, for carbon projects. And there is a lot of ambiguity in what's happening in certain parts of the world on whether banks will be allowed to get involved in carbon capture and sequestration because of its ability to perpetuate what is considered in some cultures to be a dirty business. The other issue, and is really critical in my mind. Others have said it. I put it up front. Getting a price of carbon has always been the most difficult element in getting projects going. You need the government involved to find a mechanism to price carbon, and it's happening. It's happening perhaps more slowly than it might, but the pace is there. If we can get both China and the United States to go the way of Europe in terms of putting in a mechanism with government intervention that provides for scarcity and then leads to a higher price, then that's all in good, well and good, but it's hard to do. As I tried to indicate in my presentation, getting big infrastructure projects going is dependent on government policy in multiple respects. The hub concept is there, whether you look at Europe or what's happening now in the US. It's very, and the multiple hubs in China that have different carbon pricing mechanisms for them. Hubs are part of what government can do. As Samantha said, there's a risk of government uncertainty. We certainly have had that in the United States in terms of radical changes in philosophies over the last 5 years, moving in one direction very abruptly and then back in another direction very abruptly. So consistency in policy is absolutely critical. And then other than the hub concept, providing husbanding ways to facilitate the hubs to really develop, to get the end user place, the storage facility, or the end user place for reutilizing the captured CO2, to have a mechanism for getting there from the place where there's a lot of CO2 to begin with. And government is very much critical to getting pipelines built and getting the infrastructure in place. So if we have those right frameworks, and I say carbon pricing still is the most critical element to it, whether it's done through credits and offsets or whether it's done through a market mechanism, is not as critically important as having something in place.
Great. Thank you, Ed, and thanks everyone. Guess what, folks? We are going to have to draw this to a close. Timekeeping is not one of my fortes, and we were supposed to finish a number of minutes ago. We didn't, but luckily we are going to be able to finish within that 2-hour time schedule that Asia Clean Energy Forum has allocated to us. So Ed, Beth, Mark, Samantha, Ian, Jin Miao, Kei-Yun as well, and Yamnique, thank you very much for your expert insights. It's been really nice to have you at this event. ADB, thank you for collaborating and co-hosting this event today with us. And everybody in the audience, thanks a lot for your interest in CCUS. And we hope we have brought you some interesting insights into what we can do to make CCUS progress fast. Recording will be available on our YouTube channel, and we will send a notification to all of you participants in due course over the next few working days. Enjoy the rest of ASEF and the summer that is starting, wherever you are, and thank you very much for your time. Goodbye. Thanks.